All right, so it says barium chloride is insoluble in water. Its KSP is 1.0 times 10 to the minus 6. That's a fairly decent KSP, though, for the ones we've been using. It's a fairly decent KSP. All right, so it asked me first. It asked me first to write the dissociation equation in water for this insoluble salt. So it looks like this, Ba plus 2 plus F minus, but I need a 2 in front of my F minus, yes? Okay, let me make a statement here. Any good AP Chem student knows their solubility rules by now, knows their polyatomic ions by now, knows how to write all ionic formulas and name them by now? Because notice what I did on this one. I didn't give you any formulas. I gave you the name. You have to know those formulas. So all good AP Chem students know their polyions, they know their solubility rules, and they know how to do first-year chemistry. Writing of formulas. Yes? Yes? Okay, some of us need to spend a little bit more time on making sure we got all those basics down, because AP exam expects you to know all that stuff. And this teacher expects you by your second year, by the time February is almost over for us, we ought to know those things. Would you not agree with that statement? Solubility rules, polyions, which you've had since either June, July, or August, yes. Depending on when you got that summer assignment put in your hands, yes. Formula writing. All right, so we got to know how to do that. That's just part of the chemistry. It's part of the language. Once you're into that second, third year of a language, you got to know some stuff. You got to know that background stuff, yes? Same thing is true for AP Chemistry. You just got to know those things. AP exam expects you to know that when I give you a volume and a molarity, that means you multiply them as long as your volume is in liters to give you moles. Those are just those second nature pieces that you have to be able to do all the time, 24/7. Now, to answer B, to find B solubility, all they're really asking me to do, they're asking me to find X. Now, I don't have to do the ice chart, but the ice chart might help. Z, 0, 0, minus X plus 2X is where I'm going to figure out what my KSP is equivalent to, because KSP means at equilibrium. So I don't want the zeros. I don't want the Z. I want to know what are the ion values at equilibrium. And really, some people will tell you, just ignore that side. Don't worry about that side. I don't like doing that because it is part of the stoichiometry, but you really don't have to worry about the BAF2. And you'll never know how much you're trying to get to dissolve. You'll never know Z. Now, the KSP, which is an expression of barium ion times fluoride ion squared, is going to equal X times 2X squared. That's where we end up getting our 4X cubed equals my 1.0 times 10 to the minus 6. And when I go to do that math, I first divide by 4, and then I raise that number, 1 divided by 4, which is 0.25. 0.25 times 10 to the minus 6 raised to the 1/3 power gives me an X value of 6.3 times 10 to the minus 3 moles per liter. It will always be in moles per liter. You would have to multiply it by molar mass to make it a grams per liter value. And then multiply it by 1,000 to turn it into grams per milliliter value, right? Okay, that's how I do B. How do I do C? C is very similar, except C says we don't have 0 fluoride, we have an amount of fluoride. So we just change it, not here at all. We change it right here. We change this to be 0.001 molar because we added the barium fluoride to a sodium fluoride solution. So there's already fluoride floating around. Why am I not worried about sodium? because he's a spectator. We throw him out the window. We don't worry about him. I still have minus x plus x and plus 2x. But this is where chapter 13, no, KCKP, you can't do any squiggling of x's. No, 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 no. But in KSP, because all of them are small values, I am supposed to be able to squiggly. I'm supposed to be able to say 0.001 plus 2x. I don't want to have to deal with all that extra math, even though we could, if we needed to, don't want to have to. So I usually squiggly this and say that when there's a common ion, it's not going to be changed by a 2x value. I'm supposed to be able to do that. This is still the expression, so I plug in x for my barium, I plug in 0.001 molar for my fluoride, and who knows, I got a value of this. Did you? Yes. Yes. Well, not that equals, Ms. Matney, not that. Let's rewrite that. That is x times 0.001 squared is 1 times 10 to the 10 to the minus 3 squared. Oh my goodness. 1 times 10 to the minus x. That means those go away and I'm left with x equals 1. Yes? Okay, here's the issue. That's what you would record. They're not going to give us one like that. But Hayden, that means I really wasn't supposed to squiggle. No, they're not going to give us one like that. They're not going to give us one like that. But if we had not squigglied, the value would have come out to be 0.0059. Thank you, Seth, for doing that for me yesterday on your calculator, so I didn't have to. 0.0059, which is what the real value is supposed to be. Now, why in the world does this one happen that way? Every once in a blue moon, there'll be one where the molarity is so small and the KSP is such a good value that you're going to have to not squiggly. However, they promise they won't give us one like that. So if I had made it, Brianna, 0.1 instead of 0.001, I would have been okay in the question I gave you. But I ended up giving you one of those outliers. But that's okay, because that means now we can talk about it, that every once in a while, because of the math, you really shouldn't squiggly. And in the next unit, I'm going to tell you, oh, that KA and that KB are pretty decent. That's a red flag that you might not be able to squiggly. So this is what the real answer would be if we had done all that heavy-duty math with the plug and the chug. But this is what you got, correct? Okay. The last question then is this. If I take 500 milliliters of a 2 times 10 to the minus 3 molar potassium fluoride and mix it with 500 milliliters of a 3 times 10 to the minus 3 molar calcium nitrate solution, barium nitrate solution, will a precipitate occur? There's my key question. And what does that key question say to me? Q. I need everybody to read that and go, oh, that's a Q question. And then this is what I need you to do. I simplified it for you. Beaker 1. Beaker 1, you need to say the molarity times the volume of that beaker 1 divided by the total volume of the 2 beaker volumes put together. And then you need to say for beaker 2, molarity times the volume of beaker 2 divided by total volume. And for my fluoride, that's going to give me 1 times 10 to the minus 3 molar fluoride. And for my barium nitrate, that's going to give me 1.5 times 10 to the minus 3 molar of my barium ion. And I could care less about sodium and I could care less about potassium. Now, what do I still have? I still have this equation where you have solid on the left and ions on the right. And here's where my students get confused. They want to put the ions on the left and the solid on the right, since you're starting with ions. Anybody wanted to do that? Don't do it. Solid on the left, ions on the right. Solid on the left, ions on the right. This is just one of those problems. A Q problem means you're starting on the right. What are you starting with on the right? You're starting with no solid on the left, and you're starting with 1.5 times 10 to the minus 3. and 1.0 times 10 to the minus 3 molar of fluoride. And you're trying to see, since those are my what are called initial values, it should shift towards that solid, shouldn't it? That's a 0. So technically, if he weren't a solid and this weren't KSP, I'd automatically go minus 2x minus x plus x. I know it shifts towards that 0, right? But KSP is a little different. KSP says, do you have too many ions floating around or not? That's why it's a question, Q. Will it precipitate? It might, and it might not. So here's what we do. We say Q, which is just barium times fluoride squared. I plug in those numbers of 1.5 times 10 to the minus 3 times 1.0 times 10 to the minus 3 squared. And I get 1.5 times 10 to the minus 9 for my Q. Now let's do this. How do the KSP and the Q compare if the Q is 10 to the negative 9 and the KSP is 10 to the negative 6? Yeah. Okay. All of these right here. Will a precipitate occur? I can't answer that question until I get all the way to my Q value and take my Q value and compare it to my KSP. I can't answer it until I get there. Now, here's how I answer it, Myri. Which way is my arrow pointing? Up there when I got my KSP on the left and my Q on the right, you always do it alphabetical. It's pointing towards the right. So is it pointing towards, Jordan, my solid? It's not pointing towards my solid. So, Skylar, will I make a solid if it's not pointing towards my solid? No. So there will be no precipitate. The answer is no, because Q is less than your KSP. Now let's put that in real live words that explain why there's no precipitate. I mean, that's a little formula I might have memorized. But why is there no precipitate? Hayden, I really want to know the deep part. Why is there no precipitate? And hold on, let me stop that.